In this video, we're going to look at how to solve a linear equation. An equation has an equal sign and the left-hand side and the right-hand side. And the left-hand side or the right-hand side, they could be numbers or variables. For example, we may have 3 equals 3. And in this equation, we can call it an identity, there's nothing to solve for. It just tells us 3 equals 3. But in most of the equations, you may have a variable. Let's use x to represent the variable. X minus 2 equals 7. And this is also equation because it has an equal sign and left-hand side, x minus 2, and 7 on the right-hand side. And equations all have a very good property. I listed 4 of them here. So first one, we can add a number to both sides. So I highlighted these 2 words here and not change the equation. And second one, subtract from both sides and not change the equation. Number 3, we can multiply both sides and without changing the equation. Number 4, we can divide both sides by a non-zero number without changing the equation. The reason we have to add a non-zero number here is because we cannot divide any number by 0. All right, so let's see. If, for example, 3 equals 3, let me change the color here. We can add the same number. We can add a number. This number must be the same number on the left and the right. So I added 2 to both sides of the equation. And 3 plus 2 is 5. 3 plus 2 is 5. Notice that 5 still equals 5. So when we say not change the equation, it doesn't mean the left-hand side or right-hand side doesn't change. They change. So for example, the numbers are changed from 3 to 5, 3 to 5 on both sides. What doesn't change is the equal sign. As you can see, 3 equals 3 and 5 still equals 5. So when we say not to change the equation, we actually mean the equality relation still holds. And this is a very good property because when we solve an equation, we want to get the variable by itself. See here, x, we want to get rid of minus 2 there on the left-hand side. And how do we get rid of minus 2? We know that if we add 2 to both sides, so this is the first property. We can add the same number to both sides without changing the equal sign. The equal sign will still holds. And left-hand side, notice that negative 2 plus 2 or 2 minus 2 will be equal to 0. So these 2 will become 0. X, we just copy it. We didn't do anything to x, so we copy it. And I can put a plus 0 there because negative 2 plus 2 is positive 0 or negative 0. That would be the same. And notice that x plus 0, when you add a 0, 0 means nothing. When you add a 0 to add nothing to x, x will still be x. So usually, we are not even going to put a plus 0 there because this plus 0 doesn't do any contribution. So we're going to just cross them out. So that's why usually when we solve the equations, we just go ahead and mark out minus 2 and plus 2. So that just leaves you x. And on the right-hand side, 7 plus 2 is equal to 9. So that tells us x equals 9. And we can plug it back into the equation to check. Replace this x with 9. So we have 9 minus 2 equals 7. So that is the correct answer for x. So as you can see, we're using this property. We add the first property, add the same number to both sides, and we can get x by itself. So similarly, say if I have x plus 2 equals 7 or x times 2 equals 7, I'm sorry, this should be divide by 2 here. So if I have x divided by 2 equals 7, and this one should be x times 2 here. X times 2 equals 7. And we can apply these properties to solve for x. So in this example, x plus 2 equals 7, which means I want to get rid of this plus 2 here. Let me change the color again. So how do we get rid of plus 2? We know we can subtract 2. Because our goal is to get a 0, because when we add a 0 to a number, it won't change the number. And remember, we must do the same operation for both sides. So if we subtract 2 from the left, we have to subtract 2 from the right. And now we end up with 2 minus 2, 0. Again, 0, when we add 0 to x, it's not going to change x. So we just mark them out, x equals 5. And if you have a division in the equation, we say we have x divided by 2. Notice that for division sign, we have several of them. So we have this as a division sign. We have a fraction as a division sign. So you can put it as x divided by 2 this way or this way. Or you could have a slash x divided by 2. All of these means division. So in this case, usually we like to use the fractional form as division. So I'm going to rewrite this because it would be more clear when we multiply the same number both sides. So notice that this is x divided by 2. It's a little different from minus and plus. So you divide by 2, x divided by 2, the operation is division. What we're going to do is we're going to multiply both sides by 2. Multiply the left-hand side by 2, right-hand side by 2. In that case, 2, we can put 2 over 1 because usually when we multiply fractions, it's better to change all the whole numbers to fractional form by putting a 1 underneath 2, and then you can see how we multiply fractions since we reviewed this operation last week and how to multiply fractions, multiply straight across. But before you multiply them straight across, you can reduce all the numbers possible. And notice that the top 2 cancels the bottom 2 because 2 divided by 2 is 1. 2 divided by 2 is 1. And so you will have a bunch of 1s. And notice that in the operation of multiplication or division, when you multiply anything by 1 or divide anything by 1, it's not going to change that number. So look at the left-hand side. I have 1 here, 1 here, and 1 there. And none of these 1s will change x. Let's say top, there's 1. 1 times x will still give us an x. In the bottom, we got 2 1s. 1 times 1. Notice the operation between them is multiplication. 1 times 1 will still be 1 on the bottom. So notice what I did is multiply straight across. So I have 1 times x is x. 1 times 1 will be 1. And x, for division, x divided by 1 will still be x. So the bottom divided by 1, we can also get rid of it. Okay, so look what happened after we multiply both sides by 2, because the top 2 cancels bottom 2. So for simplicity, you don't have to write a bunch of 1s. You can just cross them out. And if you remember, x over 1 is still x, and you can just write on x on the left-hand side. On the right-hand side, 7 times 2 is 14. So that's the answer. And we can plug in to check. If we replace x with 14, 14 divided by 2 is 7. All right, the last one, if we have equation of x times 2 equals 7, and notice in order to get rid of 2, we can divide both sides by 2. And when we do division, this looks like a fraction. And last week, we reviewed how to reduce a fraction. So you break down then into a product of prime numbers or just factors and see if there's anything from the top and the bottom are the same, and then you can cancel them out. And again, when you cancel them, it's like doing division. 2 divided by 2 is 1, 2 divided by 2 is 1, and as we mentioned in the previous example, 1 times x will still be x. X divided by 1, it will still be x. So that's why usually we just cross out 2's and put down x. And on the right-hand side, 7 divided by 2, you can leave it as a fraction. You don't have to change it to the decimal form, 3.5. If you want, it's fine, but you don't need to do that. Fraction is accepted answer in algebra class. All right, so here I use the example to explain these four properties, which you may be already familiar with. But I do want to point out some a few important things here. Well, first of all, notice all these four properties have something in common. So when you have equation, if you want to get the unknown by itself, and usually if there's a -2, you will be doing opposite operation of +2. If you have +2, you will be doing the opposite operation of -2. If you have divide by 2, you will be doing the opposite of operation of division, which is multiplication. So you multiply by 2. And if it's multiplication in the original equation, you will divide by 2. So as you can see, in order to get rid of something, we always do opposite operations. Secondly, if you some mistake that I saw in the past, students made before. So you may you have to remember one mistake is if it's times 2. I did see in the past some students try to subtract 2, but remember times 2. If you do x times 2 minus 2, you're not going to be able to subtract them because, again, last week we reviewed combining like terms. So 2x, x times 2 equals 2x minus 2. And 2x minus 2, 2x and 2, they're not like terms. You're not going to be able to subtract this 2 from that 2 as part of 2x. They're not like terms. You cannot simplify this any further. So don't think this 2 will cancel that 2. They can't. So that's why subtraction doesn't work. And you have to do division to change 2 divided by 2 to a 1. And then x times 1 is x. So that's the second mistake that I saw. And the third mistake, so sometimes we may have a very complicated one. Let's say 3x minus 7 plus maybe 2 plus x, and then plus 5 equals 6x minus 1. So in the past, I did see students who try to add 7 here and subtract 5 here, and then, okay, 7 cancels 7, 5 cancels 5, and this is completely wrong. The reason it is wrong is because, as I mentioned before, any of these four operations, you must do the same operation to both sides. So, for example, if I add a 2 to the left side, I must add another 2 to the right side. If you don't, you can see if I don't add this 2, what's going to happen? The right-hand side will stay as 3, and 5 is not going to be equal to 3, so the equation doesn't hold anymore. So that's very important that you have to do exactly the same operation to both sides. And when you do this, yes, 7 minus 7 will cancel out, 5 minus 5 will cancel out, but this is not a legal operation. You're not using the properties correctly. You are adding and subtracting the number from the same side. See the equal sign is right here that divides the left-hand side and right-hand side. So what you're doing here is adding a number to the left and subtracting a number to the left and doing nothing to the right-hand side. So which is not following the rules that you have to do the same thing to both sides. So this will be incorrect. And so if you add 7 to the left, you must add a 7 to the right-hand side. If you subtract 5 from the left, you must subtract 5 from the right. So the left side operations, right-hand operations, they must match. They have to be identical. But the correct way to do the problem is not really doing this. You can do this, but it's not going to help you much. So the correct way is to just go ahead and combine like terms. So minus 7 plus 5, you can go ahead and combine them to get minus 2, because negative 7 plus 5, skipping x. Technically, we are switching negative 7 and x, and combine 3x and the x to get 4x, and then continue from there.